everyone, it's Ajanette and I am here to prepare your Chapter 5 lecture videos. And so Chapter 5 is discussing states of consciousness. When we think of consciousness, we need to think of a continuum where it's not binary, we're not either conscious or unconscious, but we can have different states of consciousness or different levels of arousal or alertness. So it's definitely not an all or none phenomenon. We can move from coma to high awareness and high alertness where we're actively consciously engaged. When we think of consciousness, we're really talking about our awareness of ourselves, our surrounding, our environment, what's going on around us. Altered states of consciousness are somewhere in between along the continuum where we're not fully mentally present, and that could be during sleep, dreaming, in the event that we're taking psychoactive drugs and it's modifying our states of consciousness, and even meditation can be an altered state of consciousness. Hypnosis is also an altered state of consciousness where someone else is influencing our state of being. So we do throughout the day migrate through different levels of awareness where we have a high level of awareness and alertness. This is where we're fully conscious and engaged. Probably the best time to take our classes. We're in full control of our attention and our involvement in those classes. Most people experience that earlier in the day. We have a middle level of awareness where we're very susceptible to daydreaming. We might kind of slip into just that automatic unconscious activity, like when I'm driving, sadly, I go into automatic mode, and maybe many of you have as well, where you just you're going someplace new, but you get off the exit as if it's just your normal route. Like I commute to San Diego, I commute to Menifee. Sometimes I just get off the exit that I would normally be going to, even though on that day I'm not going there. And that suggests that I'm kind of in just that automatic mode where I'm not fully mentally engaged in the process. And sadly, a lot of our driving is in that level of awareness. And then finally, we have the minimal or no awareness where it's completely within our unconscious. And, we have the unconscious, which includes unacceptable repressed memories or thoughts such as Freud suggested, or it could also be where we lose awareness, like memory loss associated with a head injury or motor vehicle accidents, or maybe where we have anesthesia involved, or we're in a coma. So consciousness is controlled in multiple areas of the body. The brainstem, particularly our reticular formation, often controls our arousal and alertness. And then how we understand or perceive that consciousness is going to be controlled by some of the cortical areas. Our perception, memory, and attention are all influenced by the occipital, temporal, and parietal lobes. Our frontal lobe is kind of our conscious, deliberate control and selective attention. It's going to be in that frontal lobe. And then our limbic system is going to be related to some of our emotions, our memory, and then when we're engaged in learning as well. So let's talk about some altered states of consciousness. As I mentioned, there's sleep, psychoactive drugs, dreaming, and psychoactive drugs are any drugs that cross the blood-brain barrier and alter our perceptions or behaviors. Dreaming is an altered state of consciousness, and different theories as to why we dream and the significance of dreaming. And then meditation, which research has actually shown that meditation can be extremely restorative to our bodies and our minds. In fact, it can be just as effective as sleep if we are very practiced at it. And then finally, hypnosis, where someone is kind of guiding you into an altered state of consciousness, and they're leading that process. You do have to have some level of mental cooperation and willingness to participate in that altered state of consciousness. Our consciousness in general and our sleep cycles are regulated by what we call a circadian cycle or circadian rhythm. Circadian usually actually literally means based on a 24-hour cycle or time frame. And so these regulate our biological patterns throughout the day. They regulate our sleep and alertness. They regulate often our indigestion, our alertness. They can regulate our mood. Some of us are morning people, some of us are evening people. They certainly can influence how effectively we're learning. I know that if I had to take a class in the afternoon, I wouldn't be as effective as in the morning because I'm much more alert in the morning. Not too early though, because it might catch me before I can be fully engaged. It also regulates our blood pressure, our metabolism, where we're hungry at certain times of the day, and our heart rate can change throughout the day and we become more relaxed at certain times of the day. Again, most people, their rhythm is going to peak during the day and it's going to slow down at night. And sometimes we get into a little slump in the midday afternoon between 2 to 3. So again, that circadian cycle is regulated primarily by the suprachiasmatic nucleus here in the hypothalamic area. And it definitely is involved in our alertness. And then as I mentioned, the reticular formation here as well is involved. Spinal cord is going to be regulating your body processes involved in keeping your body alive. So when we talk about blood pressure changing and heart rate changing throughout the day, that's definitely influenced by the spinal cord. And then our alertness, of course, again, is going to be involved in cerebral cortex. Your pineal gland releases melatonin, and melatonin is the hormone involved in sleeping. High levels of melatonin usually increase during the evening hours, during the nighttime, and so that's when we're usually prompted to get tired and go to sleep. Lower levels of melatonin are usually experienced in the daytime hours during the day when we're more alert. So the suprachiasmatic nucleus is going to kind of pick up on the light from the visual receptors inside your retina, and they're going to send that information to the pineal gland, which is going to produce the appropriate amount of melatonin to either produce alertness or to produce drowsiness and tired. So disrupting our circadian cycle can influence our mood, our behavior, our performance. Some common disruptions that are very familiar to us might be jet lag, which can be particularly difficult when we're going. It's easier for us to go from the West Coast to the East Coast, but it's harder for people to go from the East Coast to the West Coast. And that's because, I think I just messed that up. Okay, so I'm back, and as I mentioned, I think I messed that up. It's harder for us to fly from the West Coast to the East Coast because then they're ahead of us. So if I'm in my time zone, it's 6 o'clock, and in their time zone, it's 9 o'clock. My body's going to have a harder time going to bed earlier as opposed to them flying from the East Coast to the West Coast where we're behind them. And now, even though their body thinks it's 9 o'clock, it's only 6 o'clock here. Their body can stay up later, but it's really difficult to force your body to go to bed earlier. And shift changes can be particularly problematic. Research shows that individuals who change shifts have higher rates of accidents, lower productivity, and less efficiency in their work schedules. And so one of the things that they've done, research has shown, is that it's easier for them to transition from day to night shift than it is from night to day shift. And their body needs some adjustment time, so they usually don't change shifts within like every other week. It's usually about a 3-week period, and then they have the swing shift in between to kind of transition them from going from night to day. And then sleep deprivation can be problematic if we've, for whatever reason, been deprived of sleep, whether it's finals or partying or accidents or family challenges. Then we might experience some symptoms including grouchiness, irritability, mood swings, difficulty concentrating, paying attention, increased risk of accidents, more susceptibility to microsleeps or quick, we fall asleep unless we're active and we have that kind of second wind. Sleep deprivation can actually cause a tremendous amount of stress to our bodies, and we see that through increased cortisol levels, which is the stress hormone, and it can increase our risk of accidents and death. So we need to be mindful of that. It's negatively impacting your health and well-being. And some, as I mentioned, the effects of the disruptions include, mood swings, poor concentration, you're not as productive, you have increased risk of accidents, just kind of maintain a constant state of fatigue. So I'm going to get into your sleep, just some sleep discussions. First of all, why do we sleep? There's different theories. Some suggest that circadian cycle has evolutionary or adaptive value. And so we're sleeping at night when predators might be out and about, and we're more vulnerable and susceptible to predators. So we sleep during times in which we can be protected by being immobile and inactive. And then the repair restoration theory suggests that we've expended our energy while we're awake and alert, and so sleep allows us to restore kind of like fuel to our body. It helps bring us back into that optimal condition. We do go through different stages of sleep. When we have pre-sleep, we experience these alpha waves, or we're just kind of more relaxed. And then we slip into sleep and we go through what's called non-REM stages. And we go through stage 1, which is a lighter sleep, and stage 2 is a lighter sleep. We're much more susceptible to being easily awakened during this time. And we have some some spindles and some K complexes appear in our EEGs here. Stage 3 and stage 4 delta waves start to come into play, which are much slower waves suggesting a deeper, relaxed state of sleep. And then we progress back through the cycle. So we go 1, 2, 3, 4, 3, 2, and then we go into stage 1, and we call it emergent stage 1, where we experience REM sleep. So non-REM is stages 1 through 4. REM is rapid eye movement sleep. This is a time when our brains are active and alert. EEG shows same brainwave patterns as when we are awake. The difference between the two is pretty profound. Non-REM again includes stages 1 through 4. It's lower frequency brain waves. We have decreased pulse rate, some simple dreams. We do dream during non-REM, but not as much as REM sleep. And it really serves to meet the restorative or biological needs that are met with sleep. In REM sleep, it's known as paradoxical sleep because our large muscles are paralyzed, so we can't move our limbs, but at the same time we have very active brain waves. As if we were awake, our pulse rate increases, our breathing becomes rapid, shallow, and inconsistent. And it also serves a biological need, but more importantly, it seems to play a cognitive restorative need, and that's when our memory seems to be consolidated and a lot of learning and organization is taking place over time. If we look at sleep patterns over the lifespan, infants spend almost half their sleep time in REM, and older people spend very little of their day in REM sleep. And so half the day in REM as an infant to less than 25% of your time in REM as an adult, and that may indicate lower levels of learning that are going on. Everything's new in infancy, so you're literally learning everything. And in late adulthood, that's just not the case anymore. So I'm going to stop there and come back to dreaming in just a minute. So I'll see you in a couple minutes.